Okay, so antiderivatives. Just going backwards on all of this stuff. So I'm given that f prime is 3x squared. So you have to go backwards from that. Okay? What function would give you a 3x squared? X cubed. That's beautiful. So it's going to be, f of x is going to be x cubed. I'm going to write down plus c. That means a constant. I'm going to explain why right now. What's the derivative of a constant? 0. So if you take the derivative of this, don't you still get this answer right here? Yes. But when we go backwards, we don't know if there's a constant or not. So we're just going to say plus c. Because we just don't know. The constant could be 0, could be 1, could be 2, it could be 18, it could be like 1.2345. I don't know. It could be anything. Unless they give you more information. So what's the formula here then? And you have it on your formula sheet, which is right here. So it's going to be the second one on the formula sheet. Okay? Right here. This is the formula. To go backwards. So if you have x to the r. So if f prime of x is x to the r, then going backwards, f of x is going to be, now we take the derivative, we subtract 1, right? But now we're going to add 1. So that's why it's x to the r plus 1, and we divide by whatever we just added. Then obviously your plus c right there. So number 2. What happens to that? So we just have x to the 4th. Yeah, so what's the antiderivative to give me f of x? Going backwards. If you don't know, use the formula. What's r in the formula? R is 4, so just add 1 to 4 and you get, divide it by. It's also written as this too. 1/5 x to the 5th plus c. If you take the derivative of 1/5 x to the 5th, what do you get? You should just get 5 x to the 4th times 1/5. Those 5 and 1/5 cancel out. You just get x to the 4th. So it's really just going backwards. Okay. All right, number 3. Ooh, that looks hard. I quit. All right, we're done. I'm a quitter.
Let's do it, man. I want to learn.
Oh, you want? Oh, wait. Do you want to learn, or do you just want to do well on your quizzes?
What's the difference?
Yeah. Okay. Yeah. That's my point exactly. It's funny. I was asked a question like this. So I was talking to some of my old HP kids, and they asked like, "Hey, what's the difference between LT and HP?" Yeah, LT has a Neelish. HP does not have a Neelish. So what I really told them is, which I think is a little different than here, a little bit, just a little bit. I would say 99.9% of HP kids do things for a grade, and that's it. I don't think you're 99.9. I know some students that actually are willing to learn. All of you at least willing to learn a little bit. Like those kiddos, they don't really care. They will hire a tutor the night before their assessment, cram away, and know that knowledge for approximately 24 hours, get their grade, forget about it, and wait for that tutor to show up next week. That's what they do. That's like a huge difference. And then what was so funny is I had this conversation with them over the weekend. And then yesterday we had some students, maybe someone in here, was like on a panel, and there was the question: do you learn for the grade, or do you learn for the fun of it, or do you like learn to learn? And one kid lied and said to learn to learn. Everyone else said the grade. Yeah, there's no way. The kid totally lied. No way. Right. So, all right. Just a little sidetrack. Oh, yeah, because I quit, right? That's why I said that, because I quit. All right, hey, let's unquit here. Can I rewrite this so this doesn't look as terrible? It's just x to the negative 2. Okay, so since that's not the answer. Why are we talking? This is not the answer. This is to help us get to the answer. So now, what's my r value in this case? Negative 2. So let's add 1 to that. What do you get? You're going to get negative 1. So you're going to get x to the negative 1. Divide that by negative 1 plus c. Want to clean that up just a little bit? No? Okay, let's move on. No, put that on the bottom. This is going to be 1 over x, negative 1 over x plus c. So a lot of this stuff we'll be learning today is just clean it up. Clean it up. And we've been pretty fortunate that all of our numbers have been integers. There'll be a time where we start doing square roots, cubed roots, fifth roots, 10th roots, whatever roots, and trig. Hey, let's do trig. Okay, so the derivative of what gives me cosine? So the answer is yeah, and hey, don't forget that plus c. You will forget this plus c. I'm just warning you. Practically everyone in this room at one point will forget a plus c in your life. You're going to say no, Mason? No. Not the commutative property where we can reverse it. A plus c. All right, so the function f you found is called the antiderivative of the function f. Antiderivative is given the derivative, and you work backwards. Can we stop talking while I'm trying to teach here? Can't imagine why we get low grades. And then, so what did I say c was? C is a constant. Talk about notation a little bit. So you're probably going to see this. Probably. You are going to see this a lot. Especially this part right here. I don't have highlight. Oh, I do have highlighter. You think highlighter will show on the paper? Oh, we'll find out right now. Whoa! It doesn't look very even to me. It's bothering me. Looks better. I'll take it. Someone right now is watching this video and they're gonna go blind, like ah. All right, so you're gonna see this a lot. So the little s in front, we talked about that. It's the integral. It really stands for sum. That's the whole point of it. So it's an integral symbol. The function inside is the integrand, we call it. It's the integrand. And then dx is the variable of integration. So the process of finding antiderivative is called antidifferentiation. Antiderivative can also be called an I have no clue what they want there. I'll look it up real quick. What the heck do they want?
Check your notes, man.
Do you think I teach with notes in front of me?
Well, I mean, you have before.
It's probably something stupid. All right, so it's also known as an indefinite integral. Okay. The purpose of indefinite integral is really just coming from right here. We don't have any bounds. Like when we just did problems last class, we had bounds. When we're boundless, it's just an indefinite integral. Okay, that's all that is. Okay. So if we take the derivative of an integral, we're actually just going to get the function, the original function. Questions, comments, concerns about the notation of everything? Who's ready to do some problems? As we continue today's lesson, it's a very integral part of the rest of the year. You don't integral mean that.
No, I mean it.
Oh. Alright. Hey, let's find each antiderivative. We're also going to use some of the properties we used last class. Like, quiet. This 3, he's just going to chill out front. Just like we did last class. He's just going to chill out front. So, what do I really care about here? The x dx. What's the antiderivative of x? Yeah, x squared. There's more to it. We're not done. Eventually, I'll do that last. Over 2. And don't forget about my... What would I ignore right off the bat? The 3. So don't forget that 3 right there. So 3 times that plus c. That doesn't look very clean, so how can we clean that up? I'm just going to do 3 halves. You can do 3x squared over 2. It doesn't really matter. So I'm going to do this. 3x squared over 2. I'm not bothered by any of those answers. Try 6. Try 6. Call on a random person. Neelish immediately looks at me and goes, "Don't you dare." Neelish, I won't call on you unless you randomly get selected. Are you ready? We did a problem very similar to this, so it shouldn't be like too difficult. Let me call on a random person. Neelish, give me a number between 1 through 26. Pick a number.
13.
Hey, Ayush, what'd you get?
Nothing.
Hey, you got nothing, Ayush. The answer is not nothing. All right, Neelish, pick a different number.
24.
Mason, that's you.
Alright, I got -2 over x squared.
Say it one more time.
-2 over x squared plus 8.
-2?
Yeah, that's not right, is it?
1 over -2 x to the -2 plus c. I'll clean that up a little bit because you got to add 1 because that's really going to become x to the -3. Add 1, you get -2, so it's x to the -2. Divide by that. Add c. Let's make this look a little bit nicer. And there you go. Alright, let's try 7. Ooh. Ooh. Why am I saying ooh? Ooh. Okay, how can I rewrite a square root so it's workable with what we're doing? Okay, let's add 1. Let's do it. Add 1. Did you just say 5? What's x to the 1/2? So you guys 1/2. What's add 1 to 1/2? Stop saying 5. No, it's not. 1/2 plus 1 is not 5. And we need to stick with fractions here. If we go decimals, we're gonna have a bad time. We did go with fractions. Let's go with not mixed fractions, but improper. 3 over 2. So I'm going to get x to the 3 over 2 and divide that by 3 over 2 plus c. The only problem is we cannot accept this as an answer no matter what because we cannot have a fraction and a fraction. So what do I do with this bottom? Just flip it. We just got to flip it. Okay? So it becomes 2/3 x to the 3/2 plus c. So is the answer 5?
Yes.
No. Why do you think it's 5?
It's not the worst idea. There have been worse ideas.
If you put the answer 5, I'm marking it wrong. Okay, so if you did 1.5, if you're like, okay, x to the 1.5 divided by 1.5, you won't get credit for that, unfortunately. And you need to convert it, and that's just a mess. So that's why it's easier to stick with fractions here. Hey, try 8. Try 8, and then try 9, and then try 10, possibly. I'm going to give you 3 of them to do. Try 8, try 9, try 10. I'm going to give you a couple minutes here. I'll pause the video, so if you're watching the video at home, please try it on your own. Okay, so what are we getting here? Let's bring it back. I looked at just about everyone, saw good stuff. First one, what did we get? -2 cosine x plus c. What about 9? X plus c. Okay, oh, why is it negative? Because, look at the little chart there. When you go backwards from sine, it creates a negative. Because if you take the derivative of this, because remember, derivative of cosine is negative. So we go backwards from sine, you have to have a negative. With these, we're just doing like 2 problems in one, and just add your plus c at the end. So what do we get for 10? So is this answer 7? According to your math? It's 8. 1, 2, 3, 4, 5, 6. Oh, my bad. I'm still learning. 11, most of you got here, which is fantastic. What do we get for 11? Good job, everybody. So just add 1 to that 4. That 5 comes in and then divide by 5.
So you just take them all.
Yes, you do each one individually and then put it together. Okay, let's talk about 12 because 12 gets a little bit tricky here. This is not... Shh. I know we're all excited about antiderivatives. I totally get it. You just want to talk about it. I get it. When I go home, I talk about all this stuff all the time, but my wife would kill me, so I can't. So I talk about it here. I have to pause this. I have a story for you. Okay, so the next problem here is we have a division right here. Can we please stop talking? I know how we're excited we are about math in the real world. So this looks pretty ugly right here, but I can clean it up to a problem that I can do. What if I just divide all of these by x squared? Would that work out for me? Yes, you're allowed to do that. You're allowed to take something on the bottom, a single term, not like x plus 1, divide one by x and 1 by 1. That's bad math. But you can take a single term and divide it by each of these. So now I'm just breaking this up into different math problems. So then the first one becomes, before I integrate, 5x squared minus 2 plus x to the -2 dx. So I'm just rewriting this using algebra to make my life a little bit easier. I call this technique woodchucking. Make like a woodchuck and split it up. So I split this up into different fractions. Woodchucking. I'm going to copyright that as soon as I get home. Woodchucking. So all my viewers can buy it. Sponsored by Meidenbauer's T-shirts. Get this very valuable woodchucking T-shirt. It just says woodchucking on it. That could be me. I could get a woodchuck belt. So the antiderivative of 5x squared is? Quiet, please, again. I know the excitement of math is just too much for you to bear, but we got to control ourselves. Minus 2x. This one's going to turn into a minus as well. Let's just do this one separately real quick. X to the negative 2 dx. Okay. That's going to give me x to the negative 3 divided by negative 3. Oh, add 1. Aha. I'm making sure we're paying attention. So it would be minus 1 over x plus c.
What is that number?
Number 12?
No. Like the one that you crossed out. Like
1. How can we do 13? Just multiply, distribute this out. So when I do that, I'm going to get 3x squared plus 15 minus 2, which is minus 10. Alright, you can do this one real fast. What do we get? Neelish, what do we get? No pressure. A little bit of pressure. Neelish, what do we get? I got 5. What did you get? No, you didn't. Show your work. Neelish, what's the antiderivative of 3x squared? It's the first problem we did today. Are you paying attention at all, Neelish? We are on 13. What's the antiderivative? We're going to go piece by piece here, Neelish, because you clearly need the help. What's the antiderivative of 3x squared? X to the third. Very good, Neelish. Proud of you. Plus, what's the antiderivative of 13x? Next one, Neelish. Come on. The minus 10, antiderivative of that is? Faster, please. So minus 10x. Is that it, Neelish? Are we done? Thank you, Neelish. Yeah, Neelish actually did something. Let's all clap for him. Let's set the bar that low. The bar is that low for Neelish. Don't ask him hard questions. Some of you think this is bullying. It's not bullying. It's Neelishing. Yeah. Everyone else is laughing. I mean, come on. Okay, hey, 14. No, you're not. Hey, 14 looks a little ugly. So let's change these into fractions here. So cubed root of x squared turns into x to the power of 2/3. I didn't do calculus yet. I'm still doing math. Just algebra. Simplifying here. And then this one becomes plus 3 x to the 3/4 dx. if you don't know, you just take the number on the outside, put it on the bottom. Okay, here we go. Let's add 1 to here. So what's x to the 2/3? So we have x to the 2/3. What's 1 plus 2/3? 5/3 divided by 5/3. At some point, you can do these a little bit quicker, but I still want to show you step by step. Plus 3x to the, so we're going to add 1 to 3/4, and you get. If you want, I can go down to the middle school down the street, and then they can do this problem for you. 7/4. You're not loud enough. Okay, so let's just clean this up. By flipping this, we're going to get 3/5. X to 5/3 plus. Ooh, when I flip this, what's going to happen? I'm going to get 12/7. Very good, because you got to multiply that by 3.
Oh my god. Stop saying that.
But wait, there's more. Remember that unit you did on proofs in pre-calculus? You did it for today. This is the reason you did it. Okay, so first off, look in here, the sheet I gave you. Look, is there a formula? You need to stop talking. It's ridiculous. Be quiet. Is there a formula on here that has sine x over cosine squared anywhere? Does not look like it on both sides of here. Okay? So we need to rearrange this so it looks like one of my trig things here. So what are my trig options I have? I have just cosine, that's not going to happen, just sine, I have secant squared, that might happen maybe. Cosecant squared, secant tan. Someone just said yes, I'm agreeing with you. And cosecant cotangent. You really need to rearrange it into one of those. Someone already said it's going to be secant tangent. Why is it secant tangent? Is this a true statement?
I would like to think so.
Thus far, it's a true statement. Okay? What's sine over cosine? And 1 over cosine becomes? So what's the answer going to be? So it's just going to be secant of x plus c. Alright, 16. Now I'm looking at this and I'm like, yeah, I can take the antiderivative of 1, not a problem. But is there a formula for tangent squared on there? Even doing 1 plus tangent, there is no formula on there for tangent. So we have to rearrange it. What's 1 plus tangent squared equal to? Is it secant or cosecant? You tell me. Secant squared? Is there a formula for secant squared? What does it turn into? Okay. Hey, last thing here. I'm going to start talking about that plus c a little bit. So we can solve for the plus c if we're given some information about the function. Because so far we're just given very little. We're just saying, hey, here's the antiderivative, find the original. Okay? We're going to start doing problems where it's, hey, find the, we're going to give you the derivative, find the antiderivative, and we're also going to give you a value. Okay? So I'm going to kind of skip through some of this stuff right up here. It's a little too wordy for me. These are called differential equations, by the way, which we will hit more on. There's a whole unit on differential equations. Okay, so I'm just going to hit just a little bit on it, and it really is just this bottom part right here. Okay, so a differential equation. We want to find the general solution first of this differential equation, which means we're going to integrate 3x squared minus 1 with respect to x. That's all we're going to do. So let's find the antiderivative of each of these. What's the antiderivative? 3x squared is what, Neelish? Antiderivative of that is? You said it already. What's the antiderivative of 3x squared? X to the third. Very good, Neelish. Minus x plus c. Okay, you can also find a particular solution if you're given an initial condition. So given this initial condition right here, it says that when x is equal to 2, you're going to get 4. Okay? So now let's plug a 2 in, and we should get a 4. So we're going to do 2 cubed minus 2 plus c equals 4. We're going to solve for c, and then plug that in for our final answer. All we're doing here is we're plugging in a 2, setting this general solution equal to whatever that number is. In this case, it's a 4. And solving for c. So what am I going to get here? You get 8 minus 2, which is 6, plus c equals 4. C equals. So now rewrite my general solution, but instead of plus c, it's going to become a minus 2. So x cubed minus x minus 2. Don't cry. But we have more. I'm just going to do 20. That's all I'm going to do. I'm going to skip the other ones. Not too big of a deal here. I said don't cry, but we have more. I like 28 a little bit. It's got a little problem here. It's like 2 of those problems we just did into 1. So solve the differential equation. Now, when I find the antiderivative of f double prime, I find just find the derivative. So when I find the antiderivative of this, I'm going to get f prime. Okay? So f prime is equal to the antiderivative of x squared dx. What is the antiderivative of x squared plus or x squared dx? 1/3 x cubed, you all said? Plus c? How can I find that c? Plug in the 0 and set equal to 6. So I'm going to get 1/3 0 cubed plus c equals 6. So c is going to equal 6. So my f prime is going to of x is going to equal 1/3 x cubed plus 6. You want to do it again? Yeah, we have to. So now we need to find out. Okay, so we're going to take the antiderivative of f prime to get to f, and then plug in for our initial condition. So let's do the. So f is going to equal to the antiderivative of 1/3 x to the third plus 6 dx. What are we getting for the first one? Add 1 to its x to the fourth and multiply by 1/4, which is 1/12 x to the fourth plus 6x plus c. These are not the same c's, by the way. We just, as mathematicians, just keep putting c. These c's are unrelated. If you want, I can put like a plus k, but it doesn't really matter. Okay, so we're going to plug in a what now? A 0, and we should get a 3. What happens when I plug in a 0? So in this case, we're going to get this c to equal 3. So my final answer for f of x is 1/12 x to the 4th plus 6x plus 3. That's it. So if you take the derivative of this twice, you should get this. Anyone want to do that? I didn't think so. We're done.